So you've been assigned to do number 1 through 4 on this document for homework. And so we're going to do numbers 5 through 9 together so that you can get a good understanding of it, and then you can practice and submit numbers 1 through 4 to Schoology. So first question says, how much heat, so that means we are going to calculate Q for this reaction, is needed to raise the temperature of 8 grams of lead by 10 degrees Celsius. So there's a couple things we're going to pick out. We've got our mass of our lead, and then we have our temperature change. In order to calculate Q, remember that Q is equal to the mass of the material times the specific heat of the material times the change in temperature of the material. So we are going to need to find our specific heat of lead, and you can do that by just looking it up online or taking a look at the very first page on this document. So if you look at the bottom of page 1, you'll see that the specific heat of lead is 0.130 joules per gram degrees Celsius. So then now that we've got all our pieces, we can calculate our Q. So Q is going to be our mass, which is 8 grams, times our specific heat, which is 0.13, times our change in temperature, which is 10 degrees Celsius. Remember that Q is in joules, because we've got grams and then we've got joules per gram degrees Celsius. So what ends up happening is that grams and grams cancel, degrees Celsius and degrees Celsius cancels. So our unit is going to be J, joules, for our Q. So you should get an answer when you plug that into your calculator of 10.4 joules. For the next problem, it says the temperature of a 250 gram ball of iron increases from 19 degrees to 32 degrees Celsius. How much heat did the iron ball gain? So I'm going to pick out a couple of things here. I'm going to pick out that I need to solve for my Q. That's my unknown. I know that I have a mass of 250. We do need to calculate our change in temperature. So remember that to calculate our change in temperature, we always take the final temperature minus the initial. So we'll do 32 minus 19, which means our change in temperature is going to be 13 degrees. We are going to need the specific heat of iron. So again, we're going to look at the document on, we're going to go up a page on the document and we'll see the specific heat of iron. So now that I've got all my pieces of information, I can go ahead and calculate my Q. Q is going to be equal to the mass, which is 250 grams, times the specific heat, which is 0.450 joules per gram degrees Celsius, times the change in temperature, which is 13 degrees Celsius. So remember that Q is going to be in the unit of joules. So you should get an answer of 1,462.5 joules for question number 6. All right, the next problem says the temperature of a 100 gram block of ice is increased by 3 degrees Celsius. How much heat does it receive? So that means we're going to want to find the Q. It means that we are going to have a mass of 100 grams. We are going to have a temperature change of 3 degrees Celsius, and we're going to need to look at the chart on the previous page. The specific heat of ice is 2.09 joules per gram degrees Celsius. So to calculate our Q, we're going to take our mass of 100 grams. We're going to multiply that by 2.09 joules per gram degrees Celsius. And then we're going to multiply that by 3 degrees Celsius in temperature change. So that means that we are going to get a Q of 627 joules. The next one says 10 grams of steam absorbs 60 joules of heat. What is the temperature increase of the steam? So this one is a little bit different. We are given our Q as being 60 joules. we are given our mass of 10 grams. We need to find our temperature change, and we're going to have to look at that chart again. The specific heat of steam is 1.87 joules per gram degrees Celsius. So this one looks a little bit different. We're going to have our Q is equal to our mass times our unknown times our specific heat, and we're going to actually solve for our unknown. So we have 60 is equal to 18.7 times our change in temperature, 10 times 1.87. We do want to get our change in temperature isolated, so we're going to divide each side by 18.7. And so we get a change in temperature of 3.21 degrees Celsius will be the temperature increase. And the last problem says a piece of lead loses 78 joules of heat and experiences a decrease in temperature of 9 degrees Celsius. What is the mass of the piece of lead? So again, this one is a little bit different. We have our Q, we are losing heat, so that's a negative 78 joules of energy. We see a temperature change where it is decreasing, so it'd be a negative 9 degrees Celsius temperature change. We can look at the specific heat of our material on the previous page, which lead has a specific heat of 0.130 joules per gram degrees Celsius, and we want to find out what the mass of the material is. So we're going to set it up. Negative 78 joules is equal to the mass, which we don't know, times the specific heat, which we know is 0.130 joules per gram degrees Celsius, times the change in temperature, which is a negative 9 degrees Celsius. So we're going to do 9 times 0.130 first. So we find out that negative 78 joules is equal to 1.17 times the mass. We want to calculate what the mass is. So we're going to divide both sides by 1.17. And this would actually be negative 1.17. So our negatives end up canceling out. So we take 78 and we divide it by 1.17. And we get a mass of 66.67 grams is going to be our answer. So now your homework is to do number 1 through 4 on your own.